Brad Williams, Frugal Finance, pricing flavored interest rate and currency swaps. This one's going to be lengthy. Why? Well, we're going to have some, looks like we're going to have some, does this look familiar? Bootstrapping. There's no way to get around it. It's number crunching. Plain and simple. Patience, the advent of the computer, but you need to know the fundamentals. So we're going to walk through the fundamentals. I won't be as comprehensive as I have in the past. I'm going to let you work through some of this on your own. And if you're stumbling, go back to the previous examples and just keep working at it. The price of flavored interest rate swap, we apply the same techniques used to price. The price of flavored interest rate swap, we apply the same techniques used to price plain vanilla interest rate swaps. We find the swap fixed rate that equates the present value of the cash flows from the paid fixed and received fixed sides of the swap. The zero coupon factors for the present value calculations are derived from the yield curve in effect when the swap is initiated. In using these discount rates, no assumption is made about the future course of interest rates. Instead, this pricing approach finds the swap rate terms that prevent arbitrage. That's the objective here. We will use the SFR for a plain vanilla swap as follows. In this section, we apply these general principles of swap pricing to 4 different flavored swaps: forward interest rate swap, seasonal swap, a diff swap, and a currency annuity swap. In each case, the pricing solution is to find the terms of the swap that make it arbitrage-free. This means that the present value for each party must be equal given the structure of interest rates and exchange rates that prevail when the swap is initiated. The principles illustrated for the swap in this section provide a model for pricing any kind of flavored swap. A forward swap can be replicated as a portfolio of 4 bonds. The forward swap would have to have the same price as the 4 bond portfolio. Forward swap would have to have the same price as the 4 bond portfolio. It is also possible to price the forward swap directly using the same approach that we applied to find the SFR for a plain vanilla swap, interest rate swap. The pay fixed forward swap synthetically duplicated by the 4 bond portfolio shown in stripped Treasury securities at a notional principal of $30 million in annual payments was set to begin in 3 years and had a tenure of 5 years. For that swap, the yield curve was flat at 8%. Therefore, the SFR for the forward swap also had to be 8%. We will now show how to price this kind of forward swap in a more typical yield curve environment. As the following analysis shows, a forward swap is really a plain vanilla interest rate swap with a deferred starting date. Because of this, the principles of plain vanilla pricing apply quite directly to forward swaps. The actual SOFR rate that will prevail are, of course, unknown for our perspective at time 0 when the forward swap is initiated. However, the no arbitrage rates for our contracting purposes are the forward rates for the yield curve that correspond to the various 1-year SOFR rates. Given the necessary yield curve information, our pricing problem is to find the SFR swap fixed rate that makes the present value of the fixed and floating cash flows equal from the perspective of time 0. If we look at the timeline of figure 22.12 from the vantage point of potential counterparty at time 3, the cash flows. If we look at the timeline of figure 22.12 from the vantage point of a potential counterparty at time 3, the cash flows on the forward swap have exactly the same form as the cash flows on a received fixed plain vanilla swap. Therefore, we can price the forward swap from time 0 or time 3. We begin by pricing this forward swap from the perspective of time 0. Table 22.7 presents the necessary information on the yield curve at the time the swap to be initiated. The zero coupon factors and forward rate factors have been computed from the par yields by bootstrapping. as shown above, as shown below, as shown below, as shown below. As table 22.7 shows, the yield curve is humped with par yields initially rising and then falling. The floating rates implied by the yield curve and shown in 22.7 are as follows. Here we have the instrument, we have a maturity, we have the par yield, and these are given, all right? I have a zero factor, and you remember how we did this. We're gonna have to just use this formula. And all we're doing is going up. We're going across, then we'll go up. All right, 106.35, 100 minus 6.35 divided by, and then we go back up 1 to find the zero. The forward rate, we're gonna take this number, E40, divided by 1. We're gonna take E41 and divide it by E40. Once you get this pattern down, the logic makes sense. Why does this work? You can go in and you can do the math, and you're going to see if you do some substitution, it will equate. So if you want to try to solve for the par yield or the zero, you can use that formula, and then you can do substitution and some basic algebra. Here are cash flows from treasury bonds. Okay, what are we doing? We're taking D40 up here times E50, which is going to be the timeline, E50, which is going to be 1, times E40, go back up to the 0, plus E40. And this is going to give us this price. And then our cash flows are just going to follow. And in the end, we're going to have this, whatever this number is, okay? And you can see all I did was equate to whatever this par yield is in the 0, okay? And then I assume we just add all the stuff up, okay? But that's not important. What we're looking at here is this information. All I did was sketch this out. You've seen this before. This is going to be the zero factor right here. No, that's going to be the zero coupon factor. The reason it's different is because I probably took P63. So I took the forward rate, P63 minus 1, just to come up with this zero coupon factor, all right? Not the zero coupon. All I did was take the 1 year forward rate. In order to compute the zero coupon rate, I took 105.03, took this number here, and divided by 100. Then I took 106.35 right here, and just did the normal math, okay? And similar to what we did here, all right? Probably going to be the exact same numbers, and they are. I just duplicated it. So we have 7.18, 734,682.73. I'm looking at this number here and this number. They're duplicate. We have the 1 year forward rate, which is 0.63 divided by 1. And then we're going to divide 0.64 by 0.63, which should be the exact same number over here. 1 year forward rate factor, which is 105.03, 17726, 108.5, 109, 108.6, 19, 104. All right. So this is a preview of our map. This is just a map. It's a duplicate. And then we're going to look at the two-year forward rate, the 3-year forward rate, the 4-year, the 5-year, the 6-year, and the 7. How do we go about finding the swap rate? We're going to look at this calculation here. And it's going to be D40. We're going back up here. And I don't know why I'm doing this, but it must be the coupon rate. D40. Okay, it's the par yield, so we're going to go the long way here. We're going to take this D40, the 1 year, divide this by the 0. We're going to just follow this all the way across. We're just discounting this all the way across. When I say discount, we're trying to find the present value, and it's going to be of all of this series, this swap fixed rate is 6.8684 for the par yield. Then we have to look at the SFR rate and make sure it equates to the number here, which is, it's just everything's discounted. So we have 12,154,384. And how do we get that? We take N71, which is this number here, which is our swap fixed rate, times 1 plus, and then we have our series here. We're discounting, all we're doing is discounting whatever our series is. We're just discounting this. Then we're going to discount the forward rate. Okay, we're going to use Y63. Y63, which should be the average. Okay, Y63. Nope, we're taking the annual coupon rate here, which is Y63. So now we're going to discount the whatever the series with the notional principal, And in the end, the zero and the annual coupon have to equal each other. And then the logic here, all we're doing is just finding the 2-year forward rate and 4-year forward rate. And you're asking, how accurate are these? Look, the only way to determine the accuracy is look at historical data and see if this is at all accurate. Just crunch the numbers, all right? This is just patience and just a strong understanding of the logic. The fixed rate will occur at times 4, 5, 6, and 7, and 8, and will equal the SFR times the notional principal of 30 million. What I did here? No, here, right here. Table 22.8, and my numbers may be a little bit screwy here, but you'll be able to figure it out. Details the cash flow. Table 22.8 details the cash flows, zero coupon factors, and present values for each payment. Consistent with Table 22.8, the present value of the floating rate cash flow is given by, you see this number here? It's most likely it's the forward rate. So it's going to be this number here, right here in R72. And if we look at this, most likely you're going to get, all right, this is a little bit different number here because we're using year 4, 5, 6, 7, 8, and these numbers won't reconcile, okay? So we're just looking at a hypothetical. On the fixed rate side, the present value of the fixed rate flows are as follows. Again, this is a matter of, and we're starting at year 4 through 8. Remember up the top, we said we could pick any particular area as long as we match on a one-on-one basis, an apples to apples basis. You can see if we go 0.91348 right here in P66 or M, this is year 4. And this number is P66 minus 1. Here is the calculation, 066 by 065. So we're just looking at the forward rates times the notional. And then our zero coupon rate is going to be right next door, right here. And then our present floating value is going to be 0.91348 times our principal divided by E89. That would be the the zero. And then the present value of the cash flow would be that 30 million divided by this number here, E89, by the zero coupon factor, right? And then the numbers, all right? So these numbers should match up between this series up here and then between this formula and that formula. They should add up. We compute the calculation of the SFR by equating the present value of the cash flows on the floating rate and fixed rate sides and solve for the SFR. We computed the calculation of the SFR by equating the present value of the cash flow of the floating rate and fixed rate and solving for the SFR. So now we have the 7 million equals SFR. So now we have 797,488, which I showed right here, divided by 711, and you get this SFR rate of 7.2941. Got that? And LIBOR, you can label it however you want. Doesn't mean a thing. I just didn't change it. We now show that the forward swap can also be priced from the standpoint of the time at which the comparable plain vanilla swap would be initiated. In general, this is one period before the first cash flow. For example, that would be at time 3. Cash flows are not affected by the change in perspective. Discount does change. However, because we are discounting to time 3 instead of time 0, zero coupon factors for each cash flow are obtained from the forward factors or the zero coupon. We calculated this number a little bit differently. This is shorter span. The other up above, it's going to be the 8 periods, but here it looks like we have 5 periods. And you're just going to go through this. This is a plug and chug. Once you figure out the logic here, in this series, you're going to be able to plug and chug and use the same approach. And here, we have this 8741116, and we're just using the same format. We have this SFR, and we're going to divide this 119 by 8, and we're going to come up with 072941, which matches this number here. As I just stated, once you understand the process, and can visualize this. In other words, you can say, all right, we're discounting the zeros, we're discounting the forwards amongst the notionals. They should equal. Once you start mastering this. Let's say now your job is in the swap department, and after 3 months, you're going, this is ad nauseum. This stuff just bores the crap out of me. And it will. Once you do it the first time it's, oh my goodness. And the second time it's, all right, I got it. The third time now it's a job. And the fourth time you go, how can I do something more exciting? Well, there you go. You can tear this apart. You can take this formula and do whatever you want with it. You can do the same thing here. And that's the bottom line. If you're a math genius, this is very, very basic stuff. For those of you who are really into some sophisticated and complex stuff, then implement it. That's why they're paying you the big dollars. Brad Williams, Frugal Finance. Thanks for watching.